everyone. Good evening. Dear authors and invited guests, welcome to Technical Session 4G. Myself, Richa Shah, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology. One second. Uh, this session is being organized in hybrid mode. The physical event was organized yesterday on 19th and 20th February 2024 in London, UK. And the virtual event is being held today and tomorrow, that is the 20th, 21st and the 22nd February 2024 in the online mode. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write to me in the chat box. So just before we get started, I would like to introduce you all to the session chair for today's meeting. Professor Imran Zulkarnain. He has taught at University of Minnesota, Penn State University, and American University of Sharjah. He has been involved with multiple education projects funded by the World Bank, Asian Development Bank, DFID, and GFIZ at the primary, secondary, and tertiary education levels. Dr. Nitin Sakhare. Dr. Nitin Sakhare, he is currently working as an assistant professor in the Department of Computer Engineering at Vishwakarma Institute of Information Technology, Pune. He has published more than 30 research articles in reputed journals with SCIE, Web of Science, Scopus Indexing. He has also published more than 100 books. He has delivered more than 50 training sessions across the globe and all over India. His research interests include data science, machine learning, computer networking, and Internet of Things. Sir, would you like to say anything?
Yes, thanks, Richa. It's a great privilege to be here, and we are excited to hear from all the authors, what work they have done. And first of all, I would like to wish you all the best, all the authors. Just be stick to the schedule and be just normal with your presentation. We are not here to do any critical comments, but definitely would like to hear about more about your research work. So yeah, so over to you, Richa.
Thank you, sir. So now let us start with our presentations. I would like to call upon Mr. Fuasto Granda to present his paper on the titled Analysis of Vehicular Data Communication in the Case of Cotopaxi Volcano Eruption. So please could you start the presentation?
Thank you, Risha.
Thank you.
Let me share. Okay. Okay. Could you see my presentation?
Yes, sir, it's visible.
Okay, Risha. Good morning from Ecuador to everyone. I'm pleased to participate in this 9th International Congress on Information and Communication Technology. My name is Fausto Granda, and I'll present you an analysis of vehicular data communication in the case of the Cotopaxi volcano eruption. The agenda will cover the following items. First, introduction. Next, concept and generalities. Methodology, results in analysis, and finally, conclusions. The Cotopaxi volcano, located in Ecuador, and located within the Andes Mountain, is a potentially active volcano. Past erosion has severely affected densely populated areas. In recent years, the last in 2023, the volcano presented a great increase in activity, reporting high levels of emergency eruptions of small and medium scale and stem emissions. According to statistics, 32,000 vehicles travel daily through the road facilities in this area. A possible erosion could cause the collapse of the traffic flow and affect the road infrastructure located in the path of mud flows and lahars. I'm presenting this research work in a possible path of the lahars. A vehicular congested scenario is a condition to consider in a natural disaster. So in this way, a motivation of this work is to simulate and analyze some vehicle-to infrastructure and vehicle-to-vehicle communication parameters to foresee solution and emergency activities. Some concepts and generalities. Intelligent transportation systems has focused on improving transportation efficiency. Vehicular adult networks have been developed to this end. The IEEE HO2.11p standard was developed to operate at 5.9 GHz for B2B and B2I communication. This work uses open source simulations tools to analyze vehicular communication parameters. SUMO is a microscopic traffic simulator, NS2 is a network simulator, and Quadriga used for simulation of mobile radio networks. The methodology and results of this work are oriented to be applicable in the early stage of wireless sensor network planning. With respect to the methodology, the georeferenced maps of the Cotopaxi volcano used to simulate the vehicular mobility, vehicular communication, and radio propagation were obtained from OpenStreetMap and edited using Java OpenStreetMap. The vehicular mobility was simulated using SUMO, a simulation of urban mobility. The vehicular data communication was simulated using NS2, network simulator, and radio propagation was simulated using Quadriga, quasi-deterministic radio channel generator. With respect to the scenarios, we use scenarios, key scenarios, key places as the roundabouts and roads with high car density, where the cars will flow in the case of the Cotopaxi eruption. Figure 3 shows a snapshot of vehicular flow simulation performed in Zoom. Figure 4 shows a snapshot of figures of vehicular data communication. Little a is for vehicle-to-vehicle communication in the roundabout A, and part B is a vehicle-to-infrastructure performed at the roundabouts A, B, and C. The vehicular radio propagation performed in Quadriga consider the roundabout and the communication between cars and a base station installed in the roundabout. We got some statistic of path gain and Doppler spread. The table 1 summarizes some general simulation parameters. We performed the simulation for vehicular communication using IEEE HO2.11p. The antenna type was omnidirectional, and the transmission power for B2B and B2I was 0 to 1 and 1 vatios, respectively. Some of the simulation and results are summarized in the table 2. We get some parameters of throughput, packet delivery ratio, average end-to-end delay, and jitter for B2B and B2I under TCP and UDP protocols for the scenario 1 and scenario 2. In sum, TCP offers a higher packet delivery radio and throughput levels than UDP. On the other hand, UDP offers a lower delay time than TCP. Delay and jitter time increase as the number of connections increases. Figure 6 shows evolution of the TCP throughput when two cars are connecting and the cars are going to a roundabout. In the stage B, you can see a drop in the throughput rate when the nodes enter the roundabout due to the interference caused by the high car density. When the cars leave the roundabout at the stage C, you can see a recovery in the throughput rate. With respect to the radio propagation, we simulate two cars, the communication between the base station and between cars. The base station is located in the roundabout and the cars are moving in opposite directions. We can see in the figure 8, little a, the path gain versus time. So we can note an inverse relationship between the path gain and distance. And we can see a higher levels of path gain for communication base station to car 1 and to car 2 than for car 1 to car 2. In other words, the B2I communication shows higher levels of path gain than B2B communication. Some factors as the placement of the base station, the height of the antenna, condition of line of sight, and the transmitted power are factors that can affect this kind of results. The Doppler spectrum showed a good match between the simulation and the theoretical frequency variation. In the case of the simulation, we have a Doppler shift of approximately 450 hertz, while the theoretical frequency variation is about 440 hertz, approximately 5% of the difference. With respect to scenario 2, we obtain some similar results where TCP offers a higher packet delivery radio and throughput levels than UDP, while lower delay times are obtained in UDP. Delay and jitter times increase as the number of connections increase due to interference, due to the vehicular density. In the radio propagation, we propose another configuration. Car 1 and car 2 are moving in opposite direction, and they will pass in front of the base station in the roundabout A. The path gain show higher levels of path gain when the car 1 is communicating with car 2. This is because the short distance between two cars, they are at time 10 in the same spatio-temporal position. Doppler spectrum, part B, show again a good match between the simulated and calculated. Simulations show a variation frequency about 300 hertz, but the theoretical variation frequency is 273 hertz. It's a good match. Some conclusions. In this work, open source tools have been used to analyze some parameters of vehicular communication for B2I and B2B, such as network parameters, path gain, and Doppler spread. network simulation performed using the IEEE 802.11b standard show a better performance of UDP and trend of delay time and jitter, whereas TCP outperforms in terms of throughput. An inverse relationship between path gain and distance was observed. Factors such as the placement of the base station, the antenna height, the level of transmitted power, condition of line of sight, quasi-line of sight, and roundabouts had an important impact in these metrics. Doppler spread simulation showed a good match with the theoretical results. As the number of vehicular connections increased, parameters such as throughput, packet delivery to radio, average end-to-end delay, and jitter were affected. These results are oriented to be applicable in the early stage of B2I and B2B deployment because simulations are a cheap way to obtain results. So the next steps is the use of machine learning to predict factors as from radio propagation or the use of MIMO for communication. But it's a good
Sir,
part
sorry to
in the
interrupt, but 10 minutes are over. Could you please wrap up?
okay.
Yeah.
Okay. Thank you.
Any questions about the session, chairs?
Yes, thanks, Richa. Author, a very good presentation. I would appreciate your efforts that we can see from your presentation. So I would like to ask a few questions to you. Can you just jump to slide number 13, please?
Excuse me. I can get your question.
Can you just jump to slide number 13?
Um, I can hear it. I have some the sound is not good for me. We have
Okay,
a sound.
okay. So let me go to the other question. Can you just tell us how resilient is this vehicular data communication infrastructure that you just talked about? What potential disruptions can be caused by the volcanic eruption? Can you just address this question?
Okay. Yes, one limitation of this work is site specific. So, more than the results of this simulation is the methodology we use and the use of open source tools for developing countries where the budget for research are limited. So in this way, we have limitation, but we consider these open source tools are very powerful to perform in any scenario this kind of simulations.
Okay, and for communication, you talked about TCP as well as UDP. So how you see the trade-off between the characteristics of TCP and characteristics of UDP for this data communication which is involved?
Okay, these two protocols are useful for vehicular communication. One is oriented to connections. It will depend on the application you will need for this kind of simulation. For instance, security differs from gaming. So that will be the key where you select this kind of protocols for simulation or for implementations.
Okay, fine. Yeah, Risha, I'm satisfied with the answers.
Thank you.
Okay. So no more questions? Okay, fine. So we can move on to the next participant. So now I'd like to call upon Ms. Desi Maya Kristen. So you'll be presenting their paper on design website for buying and selling property transactions to enhance customer experience. So ma'am, can you please present your paper? You can start with presenting it.
Okay, thank you. Okay. Hi everyone, my name is Desi Mai Christine. I will present about design website for buying and selling property transaction to enhance customer experience. This is research with me with my partner Jennifer Alexandra, and this is the abstract. Our the first problem is because of the COVID-19 pandemics. So we must live at home more longer than another's place, and especially in Indonesia, in our country, property is important things that we must have. So in these problems, we underlined about for buying and selling the property. And for this research method, we using qualitative with interview, and of course we using SDLC process, and for the analysis and design we using object-oriented analysis and design. And this is the introduction about the property. We know the property is important things that we must have in for take care of the family and other things. And because of the pandemics, is difficult to doing buying or selling activities, because we cannot come visit the property at pandemic, at COVID-19 pandemic. And because of that, we have a solution for that problems, and I think we can create something website design for using virtual tours. And this is the introduction. And for the virtual tours, we using the 360 degrees virtual tours, and this is our research method. For the first, we found the existing problems because of the COVID-19 pandemics, and then we do interview with I think with 50 peoples, and we get the problems, and we do a problems analysis, and then we found we do the feasibility studies, and I think we can running this design website, and we do the system analysis and design, and after that we do the implementation. And this is the comparison of the current process with the online transaction, that our suggestion for the solution for that problems. And the current process, the customer must coming into the property, and they can see by themselves. They see the about the situation of that rooms, about the size of the property, about the environment from the property. But for the online transaction, for the online process, we no need to visit the property, but we can using 360 degrees virtual tours, and from that virtual tool we can see the how long, how high the room, and about the about the uh, about the decoration, sorry, about the interior, maybe about the interior design the inside the property. And then we create use case diagram from object oriented analysis and design, only using one website, and we can contact to the sellers, and we can doing Zoom meeting or meeting by online, only by using the website, only using by website, no need to meet on site. And then we get the report from that website too. And then this is the class diagram. This class diagram, we can see the system, the website is doing the meeting transactions, scheduling or booking the house, and then the customer can give the rating for the sellers. Okay, and this is the example of user interface at the home window. And this is the user interface for the property virtual tours. And we can see we using 30-60 degrees virtual tours. And then now the information from the notification or from the icon inside the virtual tours. And this is the information inside the icon. And the conclusion, after designing the website selling and buying property transaction information system, this website can be helpful for customer who wants to see and buying property online. And because customer no longer need to see the property directly, and customer can consult with the sellers by online, and all selling and buying transaction can running more effectively. And in the future research, I think we can extend this research into the transaction after selling activity, or maybe after self-service the property. I think that's it about my presentation. Thank you. If you have another question outside this room, you can contact me by this email. Thank you.
Session says, do you have any question?
Yeah, thanks, Richa. Again, it's a good presentation by Lissy Maya. Can you just tell me how the legal compliances and data protection is taken care on your website?
About the complaint.
Uh, Legal compliances
Sorry, doctor.
you just talked about.
So, yeah, could you help me to reply your question because maybe my connection is not stable.
Okay, the question was how the legal compliances are taken care of on your website about real estate.
Okay, we can do that compliance by using that website with for the first action. Maybe you can contact the sellers first, and after that you can maybe for the next we can upgrade this application until all the problems in between inside the transaction for about buying and selling the property.
Okay,
Thank you,
and
doctor, for the question.
okay, and how the payments are taken care of, transactions.
Sorry, doctor.
Yeah, how payments and transactions are taken care of while buying and selling.
Payment. Okay. I think for now is still outside the website, but it can still using by online. But in Indonesia, it's difficult to still difficult to do with transfer with the big nominal only by online, because for buying the property we need the lawyer and others regulation that we need outside the website. But it can still confirm the payment by using website, but the real transaction for pay the property or pay or connection with the bank, I think the regulation is still outside the website, doctor, because the regulation in Indonesia is still difficult to put inside the website, but it can be for future research.
Okay, thank you. Yeah, Richa, over to you.
Thank you, doctor.
Okay, so now let's move on to the next presentation. Now I would like to call upon Mr. Federico Diano to present his paper titled Fostering Career Decision, Making Through Career Guidance Platform, the design of the Nifil OS shared platform. Sir, could you please start your presentation?
Yeah, sure. Well, good evening, everyone. I just share my screen. Just a second. Okay, should be this one. Oh, sorry, just a second. I have to set up some preferences on my PC. Okay. Sorry about that. I had some troubles with my PC. I should have solved all of this.
Okay.
So you should be able to see the presentation. Okay.
Yes, it's visible.
Sorry for the technical issues. So I'm here to present you this online platform, which is part of the Nefele project, which is a European project to foster career decision-making for adolescents through the implementation of technologies with teachers in the high school. So the platform offers a shared hub to view, download, and use open educational resources, and is designed to support adolescents in career decision-making. So this is because career choice is a critical developmental task for adolescents and young people, And the Nefele platform is some kind of a landing platform where teachers and students as well can find educational resources that can be used in classrooms, but also with as to practice tools to be more engaged in this crucial developmental step during their career orienteering. So this is very important also because the Nefele project aims at addressing the need issue, which is about young people not engaged in the search of work or not engaged in education of any kind. And it is an increasing problem across at least different European countries nowadays. So we thought that it would be beneficial to use technology and to give technological tools and materials to teachers and to students to foster career orienteering. So this is a part of a European project, which is the KA2 Nefele project, and is aimed at teachers and students as well. Its aim is to bridge the gap between teachers and their educational tools that can be used and their resources as well that can be used to foster career orienteering and to equip them with innovative methodologies that can be used to improve the adolescents' skills to construct their careers and to find their way in the work of the different professions and jobs that is waiting after the high school years. And this is an overview of the project. It is based on a trained model. So the model is designed to offer teachers knowledge and tools that can be used in classroom, as I said before. And it is founded on different theoretical foundations, which are positive psychology and the EU competency frameworks, which deals with digital skills, sustainability, and entrepreneurship and personal development. And this integration has been reflected in the design process of the platform and also the overall project as well. And it has a practical application. So this model is aimed at giving practical skills to students through the education of teachers and by giving them the skills that are needed to teach them in an innovative way. The reason why we have focused on teachers is because they are the front line of the education system and they play a pivotal role in providing students in their career transitions. So traditionally, they are not very well equipped in many different European school systems to give students this kind of skills. I just mentioned the other part of the Nefele project, which are MOOC, a massive online open course, which is aimed to teachers, the OER resources, which the platform I'm presenting you is about, the materials that are present on the platform, and the sharing platform which is being integrated with the platform I'm presenting you today. So I just skipped this part, so I've already told you. So the purpose of the platform is mainly to offer a comprehensive resource of these materials, these educational online materials that can be used as standalone by adolescents and as well to be used in classroom by teachers. So I just jumped to the platform. There is a splash screen where it displays the logo, and you can also see a tutorial or just skip it. And you can see, maybe it's better if I share this one. So The one on the right is the first screen where you can choose to, if you are a student, teacher, or other, for example, a parent. This does not differentiate the content of the platform, but it is used by just to monitor, to see which kind of users does use the platform. Then you just jump to the home screen, which is this one, where you can see Imagine the Future, Time to Play, and Time to Learn. These are the main sections of the application. And each of these has different sub-dashboards where you can find different kind of materials that can be used in the different part of the Nefele project. Here you can see, okay. Here you can see also the application just working. In this example, it is working on an iPhone. And we have designed the app to be as a web app. We have developed it with the Flutter framework, and it is based on the Firebase technology. And we made this choice to make it very quickly available on different devices and to make it also more easy to maintain the platform itself on the web. So as you can see, there are different kind of sections. I am sorry, we don't have too much time to focus on each of these sections, so I just skip forward. So we use the Flutter framework, which is also open source. So it's very important for us. It has been very important for us because this helped us to develop the platform. And we followed the ADDIE model. So we design and use a circular developmental approach with analysis, design, development, implementation, and continuous evaluation. And we took about 6 months and to implement all the materials. Actually, the platform was quite easy to build up using Flutter and Firebase, but we have to implement different materials from all the European partners of the platform. So we took about 6 months. And just going to the conclusions, our future directions is to develop this platform and to include more resources and tools, also including content that can be shared by users. For example, short podcasts by students, example from the classrooms, and everything that the participants just want to share with us, and we can use them and upload them on the platform to be used also by other people involved in this project, or everyone who wants to share and to use these materials. And as I said before, this is aimed at addressing a very important problem in education, which is the NEET phenomenon. And we hope that this can be useful to address this kind of problem. And thank you for your attention.
Federico, it's a good presentation. I really liked your topic. So just general questions for you. First is, can you just exactly tell us what is the age group of the students that you are talking about?
Yes, we are talking about high school students. So the different part of the project are aimed at different target of this intervention. So, for example, the massive online open course is for teachers, while the platform is for teachers and both for students, high school students.
Okay. And would you like to like give us information about like how is the parents' involvement in all this platform? Are the parents involved, or it's only for the teachers and students?
Well, parents are not directly involved, but they can be because they can just access the platform where, for example, they can see different kind of psychoeducational materials about education, about orienteering, getting information about different educational systems of the European partners that have developed this platform together with us. So yes, parents can be involved by collecting informations, for example, on educational systems. So the platform can be useful also for them.
Yeah, all right. Thanks, Frederick.
Thank you.
Any more questions from the session, Chair? Let's move on to the next presentation then. So now I'd like to call upon Mr. Wang for the paper titled Gate Series for the recognition using unsynchronized multivariate time series. Sir, please could you start your presentation?
Can you see the screen now?
Yes, it's visible.
So my name is Hongzhen, and I'm going to present our work in the gate recognition. The gate recognition using unsynchronized multivariate time series. So the first question is, what is a gate recognition? The gate recognition is a variety of biometric systems designed to recognize person identities by comparing people's walking patterns. I put a dataset demo here to let you know how the dataset is looking like. And the second problem is why the gate matters. Because in the biometric systems, there has already been many other systems like the iris detection or the fingerprints detection. But the gate has its own advantages, like it can be collected from the further distance, and it does not need the subject's cooperation. It is much harder to disguise. The popular methods that are used in the gate recognition are appearance-based methods and model-based methods. The appearance-based methods usually use the silhouettes or the GIs, the gate energy images, as the input features. They rely heavily on the detection of gate cycles. They perform perfectly under laboratory conditions, but easily fail in the real-world conditions. As we can see, I put some examples of the silhouettes and the GEIs. The model-based methods, they extract the subject's angles or trajectories. Pre-trained pose estimation methods improve the performance of model-based methods, and they are robust to the covariance of closing change or the angle changes. The left image is the previously used parametric method. We can see that the position of the key points is not stable. And the right image is the result of the pose estimation method. The key points of the human body is more accurate than the older methods. Our contributions is, it is the first work that is dealing with the unsynchronized data in the pose-based gate recognition field. Our method is model-based, and we propose a novel structure to solve the complicated multivariate time series problem. And our method achieves comparable performance to the other state-of-the-art pose-based gate recognition methods. I will show the results in the later pages. The proposed method is two parts. The first part is the joint-wise autoencoder for the unsynchronized gate data. We use the multi-scale time windows to extract different information from the unsynchronized sequences. And the second part is a multi-attention block that is used to calculate the interjoint relations to enhance the gate recognition performance. The experiment settings, that we use the CASIA-B dataset. It includes 124 subjects and 11 angles. 3 covariates are included in this dataset, which are normal walking, wearing a bag, and wearing clothes. As is for the pre-processing, firstly, we use the alpha pose to get the person key points positions. Secondly, the key point position coordinates are normalized by the image pixel size. And as is to the experiment results, our results achieve the best in the normal walking. But in the wearing bag and the wearing clothes, our performance is a little lower than other synchronized gait recognition methods. But it is still comparable to the performance. As is to the conclusion, the autoencoder group structure with the multi-scale time patches can be strongly robust in the temporal feature extraction of unsynchronized sequences. The autoencoder structure in our proposed method is naturally suitable for large-scale pre-training, which will also benefit and accelerate the real-world gait recognition applications. And the multi-attention block is proved efficient to enhance the interjoint relations to improve gait recognition performance. For the future work, firstly, we decide to apply our method to larger datasets. Secondly, the covariate-oriented features and the feature contrastive learning should also be introduced to this structure. Thank you very much. Any other questions? Oh, sorry, I closed the share room, sorry.
Any questions from the session, Chair?
Hong Sen, it's a good presentation. Again, I really liked your topic. So can you just tell us about like what are the limitations or drawbacks with the GET series approach, and how would you like to address these drawbacks?
Do you mean the limitation to the proposed method?
Yes. Yes.
Yes. The limitation to our proposed method is that our method needs a large number of dataset to let the model to give out a good performance. But currently, we just validate our method on a medium-sized dataset. So we cannot know the best performance of our method until now. So in the future work, we decide to apply this method to many larger datasets, and moreover, we also decide to enhance our structure to let it be suitable to be pre-trained on the summary of all the gate datasets. And I beg pardon for the second question.
Yeah. So are there any privacy concerns that you would like to address? Because you are capturing the data of certain individuals, their walking patterns and all that. So do you feel, are there any privacy concerns will create an issue?
Do you mean the privacy of the data collection?
Yes.
Okay, so that's a very good question. So firstly, it should be a question because the faces of the subjects that that are shown in our dataset are not occluded. But all the subjects have signed they agreed to publish this dataset. So currently it's not a problem. But when we want to implement this method to the real world, for example, if we want to track the criminals, I think it's beneficial to the society. The benefits is more than the disadvantages.
Yes, agree. So based on the case studies, case to case, I mean the situation can be different. That's we totally agree. Yeah. Thanks, Hamzan. Richa, over to you.
Thank you very much.
Okay, so moving on to the next presentation. Now I'd like to call upon Ms. Mariana Ivanova for the paper titled Bridging the Gap, Implementing CTS2 and FHIR Compatible Terminology Server. Ma'am, can you please start the presentation?
Hi again from my side. So I will ask just to be sure, can you see my screen that I'm sharing right now?
Yes, your screen is visible.
Great. So my name is Marina Ivanova, and topic for today is Thermix, bridging the gap, implementing CTS2 and FHIR compatible terminology server. To start with introduction, this topic was gained after one research, what was comparative analysis of clinical terminology servers, a quest for improved solutions. So we made some analysis and we didn't find a terminology server that will be suitable for our criteria and decided to develop our own terminology server. This research delves into implementing common terminology services like CTS2 standard on PostgreSQL, a robust open source relational database. To start with, I will just make some introduction to building blocks of terminology model. We have two main concepts. One term is concept. So a concept is an atomic unit of thought that present medical entities. This can be like diseases, symptoms, medications, procedures, and laboratory tests. And also a bigger one, a term is like code system, is a managed collection of uniquely identifiable concepts with associated designations, properties, associations. And these most common are SNOMED, CT, and LOINC. Here you can also see the design of the system. So concept are part of code system. They can be many in the code system. So also code system has a versioning mechanism. Code system has a lot of versions, and also concepts has a lot of versions. Versioning is very useful because always healthcare data evolve during the time. So new concepts appear, new designations, new properties to concepts appear. So we need a proper versioning system. Why we decided to use CTS2 as a standard to implement our terminology server? Because of standardization interoperability, flexibility of CTS design, mapping across referencing. CTS enables to map and cross-reference concepts across different terminologies, also because of versioning. CTS enables powerful versioning mechanism, community adoption, and also integration with health information systems. Like different standards, like a FHIR or different more standards. So about FHIR, what is it? It's like HL7 fast health care interoperability resources is a modern healthcare data exchange cornerstone. FHIR is like standard that describes a lot of topics in healthcare module, and also it has one separate module just for healthcare terminology, which we're focusing on in this topic. So is a crucial component within the standard, focused on managing and terminologies, codes, concepts used in healthcare information exchange. And in this topic, we are comparing two standards like CTS2 and FHIR. And while comparing, these both standards has their own way of implementation terminology. CTS2 on this picture, you can see it's more complex, it's more powerful, and FHIR is more like simple, they have more simple way of presenting terminology. The comparison of these two standards, they are conceptual modules for terminology. What we can say about FHIR, the absence of divisions into code system and versions. Each version exists as an independent resource called code system. Concepts are not separate resource, so they are just inside code systems, and that's all. And for CTS2, each version is treated like a separate resource with dedicated organizational structures and more comprehensive system, providing a robust version of a full offering capability support. So what we can say in conclusion, that CTS2 is a more complete system suitable for tasks involving versioning and comprehensive authoring, and FHIR is predominantly utilized for streamlined publication of finished versions. So about our database design, we didn't implement full CTS2, but all unused entities that are described in CTS2, like jurisdictional domain, usage context, they all can be added as needed. What was changed to CTS2 implementation, to enhance comprehensibility and readability, we just streamlined some of names, because CTS2 have too complex, too long names. And what was added, for more robust querying experience, we introduced new columns and relationships just for database querying, and incorporated additional columns to align with FHIR resources. CTS data model to FHIR terminology resources, how we did that. FHIR terminology model is more primitive, like we saw on the picture, and FHIR model can be considered as a subset of a CTS2 model. First step was aiming to identify the most suitable CTS2 attributes that align with the contextual meaning of corresponding FHIR attributes. And the second step, if direct match wasn't found, so the flexibility of CTS2 allowed us to add new attributes. And all this solution can be found in open source project called Termix. So it's just a small part of Termix. What Termix provides is adhering to the latest standards of FIRE and CTS2. Also in chasing the import capabilities, it supports FIRE. So also we provide a multilingual clinical terminology, resource descriptions, and web user interface. And also internal data models are aligned with widely accepted standards like CTS2. So maybe to talk about what was the most criteria that we didn't find in existing terminology servers. They were adhering to the latest standards, bad import capabilities, not supporting multilingual clinical terminology, and a lot of terminology servers that currently exist, they use their own internal data model for terminology storing. So we wanted to standardize also the internal way of storing terminology. And also, if you have some interest, what we talked about to see is the solution. So you can visit this link. There are tutorial. Also, you can see that this environment is also the environment of Termix. So we have our own wiki implementation. So it's just a powerful tool where you can manage terminology, you can manage your own wiki, create tasks flow, and many more other things. So, and that was all from my side. Thank you. You can see here bullet points that we got through today. So if you have some questions, I will be glad to answer them.
Yeah, Marina, thank you for your presentation. Have you really gone through any use case or real life case scenario where this implementation has been
Okay.
utilized?
Yes, the Termix currently is used in Lithuania. So their national terminology is managed through Termix. Also, we currently are implementing this solution in Estonia. So we are managing and transforming, because in Estonia we currently have stored our terminology in CSV files, and now we are going on the standard FIRE. So we are transforming these CSVs and importing them through Termix. So yes, currently it's used in the real world also.
Okay, yeah, thanks. And your major work was on comparative analysis, am I right? Correct me if I'm wrong.
You mean the first study, analysis of clinical terminology
Yeah.
server? Yes, we had a first study. We have also an article about that, a quest for improved solutions. So there are a list of criteria. The criteria was also searched through research papers that point out that these criteria are meaningful. And after that, we did our research, what are current solutions for terminology servers, and we have a comparative analysis. And as a conclusion of this first part, we didn't find the server that will suit and provide all criteria that are important. So that's.
So would you like to list down those criterias or the factors which you considered for comparative analysis? Can you just name them?
Yes, it was a multilingual possibility of terminology servers. So a lot of terminology servers and just one for one language, basically in which country it was developed. So it just depends. And also the internal data models were different and not standardized. So, okay, they all provide FHIR endpoints, but how they store their data and how they provide internal endpoints was not in a standard way. So when healthcare systems want to interact with the terminology server, they need a lot of development and not a lot of analysis of their internal models. So it's better to make the standard way, and that's why we used the CTS2. And also the bad import capabilities. So servers just accept FHIR resources in a JSON or XML way, but no CSV imports, for example, no other file imports were enabled. So yeah, these were the major criteria.
Okay, yeah. Thanks for your elaborated answer. Thank you so much.
Thank you for your question.
Okay, so now let's move on to the next presentation. Give me a second. So now I'd like to call on Hadiza Yusuf for the paper titled Towards Reliable DTMF Recognition, a Tiny ML Approach. So please can you start your presentation, ma'am?
Thank you so much, Risha. Good day, everyone. Let me just present my screen. I hope everyone can hear me.
Yes.
Yes, you're audible.
Sorry. Okay. I couldn't find the particular window I was looking for. Okay, yeah. So it's my screen sharing. Can you see my screen?
Yes, Hadiza. Please go ahead.
Okay,
Yes,
thank you
yes,
so
it's
much.
visible.
Thank you. So I am Hadiza Yusuf, and I'll be presenting a paper on Towards Reliable DTMF Recognition, a Tiny ML Approach. So this is my agenda. We'll talk about the background, the problem, motivation, review, methodology results, then conclude, and then future works. So DTMF, which fully means dual tone multi-frequency signaling, is a telecommunication signaling system that is used for voice band over telephone lines between telephone equipment and other communication device. It was first developed by Bell's Lab in 1963, and back then it was known as the touch tone. So initially, telephones uses the ring kind of system, but when Bell's Lab developed the tone system, it was switched to using keys for telephone signaling. So dual tone is made up of 8 frequencies. It's made up of 8 frequencies, 4 high frequencies and 4 low frequencies. So the keypad is is the telephone keypad, which was used, is laid out in a matrix form with push buttons, 16 push buttons that are formed by combining two tones. That's one low tone and one high tone. Dual tone multi-frequency is standardized by as an ITU recommendation, and then it is also known in the UK as MF4. So, like I said, it was originally developed for automated long distance calling, but now it has expanded to diverse field, and it is being applied in diverse domains like automation, home automation, robotics, security, IVR, and the likes. So initially, dual tone multi-frequency is being detected using classical algorithms. One of such algorithms is the Guatzell algorithm. It's a digital signal processing method for efficient demodulation of DTMF. Guatzell particularly use something similar to discrete Fourier transform, but in Guatzell, what makes it different from discrete Fourier transform is that it selects some frequencies and for some frequency components, and then converts it to the frequency domain so that you are able to know the presence of that frequency in the signal, just like we can see here. So it's telling us the presence of each of these frequencies in a particular signal. Yeah. So the problem was that even though Guatzell algorithm and other classical algorithm were good detectors of DTMF, but they are not actually robust in the presence of noise or distortion in the channel. So importance of robust DTMF performance in various deployments. So since it's not used only in a single channel, classical algorithms fail to correctly detect these tones when there is noise or distortion. And then the need for also precise timing and performance degradation is low using signal to noise environments. So another problem is also since DTMF is being used in several applications, especially applications that uses low resource equipment, the size of whatever is being pushed to those equipment is very important. I'll talk more on that further. So our motivation was that, first of all, we observed in a study in 2020 that even with the coming of speech recognition and other technologies we have currently, there is still a vast majority of use of DTMF in industries, several industries. So because of a lot of limitations that goes with other kind of technologies. So our motivation was for real-world robustness, low power capabilities, the speed and efficiency, reduction of size, hybrid approach, customization potentials, and also inferences on the device. So some of the literatures we've reviewed, because our approach was taken from classical algorithms to machine learning algorithms. Some of the papers we reviewed showed that there are some attempts, there are some efforts that have been made to use machine learning models to detect DTMF signals. But these models focused only on the accuracy of detecting DTMF signals in the presence of noise, but there was no consideration of the size. And size is very important, like I mentioned before, because of the diverse applications DTMF is currently used in. So that is the gap we were able to discover from this. And then, so our methodology was to, first of all, generate data sets using Python programming. We generated a total of 22,400 training data sets. And we, with 100 milliseconds of tone, using 8 kilohertz sampling rate. So we divided these data sets into 80% for training and 20 for test. And then we also added noise and distortion to mimic real world situations. So like you can see in this figure, this shows how the pure tones look. So, but when we add noise and other kind of distortions, we have a kind of lousy signals. So our data set was in 4 different forms. We generated pure tones, and then we also generated tones with Gaussian noise, and then we generated tones with a little bit of song and talk, just to mimic situations whereby the channels is an airway. Yeah, so, and then we generated data sets having Gaussian noise, then song and talk as well. Processing of the data sets, first of all, we did an extraction, a feature extraction by convolving the tones to get 8 pure DTMF frequency signals using a sine cosine component extraction. And then we calculated the power of each of those components, and we normalized it and also shuffled it. So to select the model, like I said before, there are several attempts to use machine learning models for DTMF detection. Now, these models actually perform very well based on these studies, but selecting the model, we were keen about how the size of the model could be. Now, we opting for ANN because, first of all, KNN, models like KNN are parametric, are non-parametric rather, sorry. KNN are non-parametric, and because they are non-parametric, they don't learn any weight or any parameter, but when deployed, they are being deployed with the data set that shows the pattern or what can be used to get inference. So deploying a model with the data set can have a huge impact on the size. So that's why we opting for ANN, which can easily be compressed, and then we can compare the accuracy of the compressed model and the model that is not compressed. So our model architecture was just a simple neural network with 2 layers, with 2 hidden layers. So the model architecture flows sequentially using 64 neurons in the first hidden layers and 32 in the next hidden layer, and using ReLU activation. So now the results we got from the experiment, so both the quantized and the non-quantized, okay, I think I missed a slide. Maybe I mistakenly deleted it. Yeah, so after running our models for each of after training the model with each of those data sets, we quantized the model, which is optimizing the model to reduce the size and from what we have, we got that both the quantized and the non-quantized model achieved nearly identical accuracy compared to the original ANN. So the quantized model, we were able to reduce the quantized model to 70% of the size of the original model, and we had significant accuracy of approximately 97, which I think would be reflected on this table here. So the pure tones were perfectly detected, but the tones with noise, the tones with like Gaussian noise, songs and talk were also good, but something that was surprising or amazing was that the quantized model performed as well as the model that was not quantized, even though the size was far smaller than the model that was not quantized. And this, we were able to understand that it is because sometimes quantization helps in regularization of a model, and regularization reduces overfitting for a model. So it's possible that our model, our quantized model was solving the problem of overfitting. So the conclusion was that this work really demonstrates the potential of using tiny machine learning models for accurate and robust DTMF recognition under noisy circumstances. And then our architecture was able to achieve above 97% accuracy, and quantization optimization enables like reducing the model to a very smaller size and still not having impact on the performance. So also deployment on a low power Arduino can pave way for integration to real world applications. Future work, we intend to not just generate data sets using Python, as it does not really mimic real world situations. So what we want to do is to capture data sets using a device that is readily available, say like an Arduino and a PC. So we captured the data set using an Arduino and then use those data sets to train the model. So capturing the data set using an Arduino would allow for noise and distortion to be included in the signal without our interference. So, and we also want to perform a comprehensive performance evaluation on the hardware setup.
Excuse me. Sorry to interrupt, but almost more than 10 minutes are over. Please, could you wrap up?
Yeah, thank you. I'm almost done. So, and then we intend to do assessments based on power consumption, accuracy, and the trade-off in real-world scenarios. Thank you.
Any questions from the session, Chair?
Yeah, Hariza, it's a good presentation again. I really like the combination of ML algorithms that you considered and come up with a new approach, novel approach. So have you calculated any signal to noise ratio while doing these experiments?
Signal to noise ratio.
Yeah.
Okay. Yeah, when generating no, we didn't actually calculate signal to noise ratio, but we looked into the ITU recommendation for how the standard for DTMF tones. So when generating the data set, we had that in our consideration. It's in the paper, but I didn't add it on the slide. So the noise was I've forgotten the exact number, but that was the standard that was followed to generate the signals.
Okay, and one more question. In result table, I saw you have put the result with quantization and without quantization. Am I right? Yeah.
Yeah.
Have you done any modulation of the signals? Like, what is the purpose of considering it with quantization and without quantization?
Yeah, the purpose is because we want to, okay, we were expecting that when a model is reduced, when the size of a model is reduced, there will be an impact on the performance of the model based on accuracy. So that was our expectation. So we were trying to see, okay, what kind of impact can reduction of size be on a quantized model. So that is why we're comparing the quantized and the not quantized to see, okay, was there any impact even after reducing the size of the model?
Okay, yeah, got it. Yeah. That's it from my side. Richa, over to you.
Yes.
Thank you.
Thank you. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We'll be happy to have you in the 10th version in 2025. All the presenters would be given their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer Journal. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also thank our session chair, Mr. Imran Zulkairan and Dr. Nitin Sakare. A token of appreciation to the chair on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, sir. So now, before we end the session, I would request you all to switch on the camera for a quick snapshot of the virtual conference. Can everyone please switch on the camera?
Richa, looks like there is some problem with my camera. Please pardon me.
Okay, sir, no
There is
problem.
some random text.
Okay. Thank you, everyone, and have a good day.
Thank you, Risha.